Alright, and now let's take a look at example 8. This is dealing with an elliptic paraboloid. And so this one we're asked to classify the quadric surface x squared plus 2z squared minus 6x minus y plus 10 equals 0. So yeah, I already told the answer, but it's showing it how it is also difficult here. So by completing the square, we can rewrite this equation. So we're going to do some completing the square to get this in that standard or just more tangible form, because we have this x right here and the y. We want to get rid of those, and we can do that with completing the square. And in this case, there's no y squared, and there's no other variable besides there's no other separate variable besides x. So we can complete the square with x squared and x. And then we're going to have a y variable by itself, that's to the power of 1. And then the z squared is already to the power of 2 with no other variables. So by completing the square, we can rewrite this equation as, so I'll write this down with all of the relevant parts for the completing the square in front. So we'll have x squared, and then minus 6x plus 10, and then so we just added this part in front just to make it easier. And then we're going to have plus 2z squared, and then minus y, then or minus y, then the other part. Minus y, and then my plus 2z squared equals to 0. Or actually, better yet, because this is one variable, I'll move that over to the other side. So we're going to go plus 2z squared, move the y to the other side. So we're going to have equals to y, just because it's different from the others. So now we're going to complete the square. So I'll put CTS for completing the square. And recall my earlier, how to do that. This just means, well, we want to get it in the form of this way. X minus a squared, and if you expand this out, you're going to get x minus a times it by x minus a. And then this is going to be, well, so x times x, then x times a, so we're going to have x squared. Then we're going to have a minus x times a, but then we'll also have another one here and here. So minus a times x again. So x times negative a, and then you have negative a times x, so it's going to be a 2. Ax, and then we'll have negative a times negative a. It's going to be negative plus a squared. Negatives become positive. So plus a squared, like that. Yeah, now if we compare it with this part right here, we're going to need, well, this part right here, negative 2a has to equal to this part. Because if x squared minus 6x, and then this a squared, we can manipulate this, tend to get that like that. But this is the key one. So negative 6 has to equal to negative 2a. So in other words, we're going to have negative 6 negative 6 has to equal to negative 2a. So what we'll do is, well, this becomes positive, and then divide this out. Divide this out. You're just going to get a equals to 3. Negative 2 times 3 is negative 6. So that's what we have. And so that's a is 3, and also a squared is going to be this part, equals to 9. So a squared equals to 9. So that means we could rewrite this as x squared. We'll just put this all out. So x squared negative 6x plus 9 to get the a squared, and then put a 1 like that here. So we split the 10 into 10 plus 1. Then we could also move it to the other side. We'll do that later. Plus 2z squared equals to y. And now what I'll do is, let's block this out, completing the square. Yeah, just block that out. Yeah, actually just put it for both sides. So we have that. And now this part right here, this is just this equals to x minus a squared, which equals to x minus 3 squared. So what we get is, we're going to get x minus a squared, or x minus 3 squared, and then put the 1 onto the other side, and we're going to get here 2z squared equals to y minus 1. And I'm just going to bold or circle this one like this. And so now comparing this equation with table 1, and here's I copied and pasted that part. into here, we see that it represents an elliptical or elliptic paraboloid. So here's elliptic paraboloid equation. So we have z divided by c equals to x squared plus x squared divided by a squared plus y squared divided by b squared. And if we look at that right here, well, we have this x minus 3 squared and then plus the 2z squared, and we have y minus 1. The only difference is instead of y squared, we'll have z squared, and then the y is there. So and then right here, we were told the variable rate. So the first part indicates the axis of the paraboloid. So this one's going to be actually along this axis here. But also, this is also shifted because we have this negative 3 there, and also y minus 1 is actually going to be shifted somewhere across here. And we'll illustrate that. And yeah, we can write this in this format. I'll just write it for completeness. And so what we're going to get is also, I'll get this part right here. So x minus 3 squared plus 2z squared equals to y minus 1, and then just divide it out by 2, and just divide everything by 2. We're going to get x minus 3 squared over 2 plus z squared over 1. And yeah, for completeness, we'll just put a square root 2 over 2. Like that. That's just 2. And this one's just going to be 1 squared. And this equals to y minus 1 in bracket, indicating it's shifted. And this is going to be divided by 2. So square root 2 over, actually this one's just c, so we don't need to do that. Divided by 2. Yeah, so that is our standard form. That's our standard form like that. And yeah, it's going to be like that, but shifted. So it's shifted by this negative 3. And this one is the z part's not shifted, so it's going to be on the xy plane. And this is y equals 1 shifted by 1, shifted by 3. And here I stated that, so here, however, the axis of the paraboloid is parallel to the y-axis, and it has been shifted so that its vertex is the point 3, 1, 0. And when you have this minus there, so basically it says to get to x equals 0, you need to put x equals 3. So you basically is shifting everything. And to get to y equals 0, you need to put y equals 1. And then the z is not shifted, so it's 0. And the traces in the plane y equals k for k is greater than 1 are the ellipses. So here, let's just put the plane y equals k. So this is going to be the vertical plane. This is going to get x minus 3 squared over, or just ignore that. We'll just go back to how it looked like. So this is simpler, x minus 3 squared, and then plus 2z squared. 2z squared equals 2, and this is going to be k minus 1. Like that. And again, these are ellipses if, the only way we get ellipses if this is going to be positive, because then we get divided out. So then k is going to be greater than 1. K is greater than 1, so then, for example, 2 minus 1 is 1, 3 minus 1 is 2, etc. So k is greater than 1. If k is greater than 1, like that. All right, going further, the traces in the xy plane and the x equals 3 plane are the parabolas with equations, and recall the xy plane. So if you have an x like this is y, so that means this plane, so that's the z equals 0 plane. So we'll put z equals 0. So z equals to 0. We're going to get, well, this part vanishes, and this is the y. We'll move it over the one on the other side. So what we'll actually get is y equals to x minus 3 squared plus 1. And this is a parabola. And it's shifted up, and it's shifted to the on the y-axis by 1, and then it's also going to be opening positive sign on the y-axis. And then the x equals 3 plane, the reason is that because this is shifted. So if x equals to 3, we're going to get, this vanishes to 0, so we can't just put 0, 1 vanish. And then the next one, this is going to be similarly, y equals to, move the 1 over, this is going to be 2z squared plus 1. So again, shifted there, this on the vertical side there. So vertical parabola, this is the z, and this is the horizontal parabola. Again, all shifted by 1 there, and this is shifted also the 3 on the x-axis. And we can see that because this is the x equals 3 plane there. Alright, so now going further, we can draw this out. So the paraboloid is sketched in the figure below. So it's going to be shifted over to the 3, 1, 0. What I'll do is I'll put this down here. 3, 1, 0. then it's going to look something like this. It's going to have, it's going to open up like this, and it's going to have axis like that. I mean, it's going to be horizontal parabolas on the z equals 0 plane, and then the vertical parabolas on the x equals 3 plane. So we're going to go, this is going to be up to 1, and this is going to be the x. This is 3. This is 1. Yeah, this is going to be 3. And then this part is the, keep it going like that. This is the y, and this is the z, like that. And what I'll do is I'll shift this down a bit, so we can have a better, a better z axis. So z is like that, and yeah, that's 3. This is going to be 1. Yeah, so shift it, and it opens up like that. So that's pretty cool stuff there. And this, because it's, yeah, 3D, like that. And this is a y. Yeah, so that's pretty cool stuff. And now, yeah, if you just graph it at GeoGebra, we're going to get this part right here. So there's our equation, x squared plus 2z squared minus 6x minus y plus 10. It automatically does everything, and it graphs it like that. And we can have a look at it. So unhide this one. Show this equation. There is our, this is a paraboloid. Yeah, or more specifically the elliptic paraboloid. So yeah, that was the name. So the elliptic paraboloid, and yeah, that's pretty epic stuff there.